In this video, you'll learn the fundamentals of the Symfony PHP framework by creating this simple web application. Throughout this project-based tutorial, I'll cover all these concepts, from installation and framework fundamentals to working with databases, validation, and so on. To follow along, you need to already know PHP, including how to work with databases and how to use classes and objects. You'll also need to be familiar with how to install third-party packages with Composer. I'll explain everything else throughout the rest of the video. To code along with me, you'll need to have PHP installed, along with a database like SQLite or MySQL, and Composer. You'll also need a code editor. One of the simplest ways to install PHP and MySQL is to install a package like XAMPP. Composer has simple installation instructions on its website, and if you need a code editor, I recommend Visual Studio Code. These are all free and readily available. Symfony provides a command line tool that helps us manage applications from the terminal. This is optional, but it does make things easier, and is the recommended way of managing Symfony applications. It's quick and simple to install. There are full instructions in the official documentation on how to install this, for Windows, Mac and Linux. Note that you only have to install this once, not for every Symfony application. Once installed, on the command line you can run the Symfony command, and this will show you some common commands. The first command we'll use is check requirements, or alternatively just check rec. This will tell you if your computer meets all the necessary requirements for running a Symfony application. If it does, you'll see output like this. If not, it will tell you what you need to install. Next, we can create a Symfony application. This can be from any folder you like on your computer. To create a new application, we run the Symfony new command, followed by the name of the application. This can be whatever you like, but I recommend you keep it simple and lowercase. I'll call my application Demo App. This will create a folder called Demo App, and in there install the files and folders needed to run a basic Symfony application. If we go into that folder and list its contents, we can see what it's created. Let's open this folder in my code editor, and there we have several folders and a few files, some of which will be familiar, such as composer.json and the vendor folder. Before we write any code, let's run this in a web server. Back on the command line, let's run the command Symfony serve. This starts the built-in web server, which is the most convenient way to run a Symfony project. We get a message saying that the server is now running at this address. If we open that in a browser, we get the Symfony welcome screen. If you want to stop the server, just press Ctrl+C. Let's run it again, and I'll keep it running for the rest of this tutorial. For any further command line work, I'll open a new terminal window. So where is this content coming from? The default file in PHP is typically index.php, so if I add that to the URL, we see the same output. If we look at the code, that file isn't in the root of the application. Instead, in a Symfony application, all files accessible from a web browser are in the public folder, and there's the index.php file. However, if we look at the content of this file, there's none of the output we just saw in the browser. Instead, this file is known as a front controller, and controls all access to the files in the rest of the framework. Note that the code in this file is part of the framework, and we never need to change it or edit this file. If you want to, you could create a PHP file in the public folder and access it in the browser. For example, let's create a file called hello.php, and in here add the PHP opening tag and output a message. So in the browser, if we open that file, we see the message printed out. However, although you can do this, this is not how we output content using Symfony, so let's delete that file. Instead, we use controllers to output content. When the framework was first installed, one of the folders is called src, short for source. This is where you put all your PHP code when developing a Symfony application. Inside this folder, there's a folder called Controller. Let's create a new file in here called homecontroller.php. Note that you can name this file anything you like, but it's convention to include the word controller, and so that the framework can load it automatically, we use Pascal case to name it. In here, let's add the PHP opening tag and the class name. Note we need to match the class name to the file name so that PSR4 autoloading works, and for the same reason we'll put this class in the app controller namespace. Then let's add a public method called index. For now, inside this method, let's just use echo to output a string. To enable the framework to run this method when we run the application from a web browser, we need to add a route. Routes define which action to run for each incoming URL. You can define routes centrally in a configuration file, but the recommended way to do it is to use PHP attributes. This way we can define the route that an action method will respond to in the same place as the method itself. So let's add an attribute before the index method. In here we'll specify the route class with an argument of the path that this will match. So in this case a single slash to match the homepage URL. This route class is part of the Symfony framework, so in order to use it like this we need to add a use statement to import this class into the current namespace. Don't worry, you don't need to remember this path. Later on we'll see how these can be generated automatically. In a browser, let's go to the route path and we get an exception. However, we do see that message printed out, which means we've connected the URL to the action method successfully. As for this exception, this helpfully tells us that the controller must return an object of this response class, but instead it returned null. In Symfony, action methods in controllers must return a response object. So first, let's add a use statement for the response class, and also for completeness, add a return type declaration to the index method for that class. Then, inside the method, instead of using the echo statement, let's return a new response object, passing the string to that object's constructor. Now when we run this, we just get the message and no exception is thrown. So now we can send content to the browser. If you want to send more content, for example a full HTML document, then you could write it out as a string from within a controller method, but that could very quickly get messy and hard to maintain. Instead, in a framework like Symfony, we put contents like HTML in separate files called templates. Templates in Symfony are created using a library called Twig. We can install this with Composer using this command. Note how Twig is a standalone package, so you can install it in any PHP project, even those that don't use Symfony. However, installing this package will not just install Twig, but also integrate it into the rest of the application. This uses a Composer plugin called Symfony Flex, which was installed automatically when we first created the application. Symfony Flex basically modifies the behavior of Composer so that after a package is installed, additional commands can be executed. The package that will be installed is referred to as a Symfony bundle, which in addition to the third-party packages can include additional files and folders. So let's run that command on the command line, and we can see that in addition to Twig itself, several other packages have been installed that help to integrate Twig into Symfony. Also, back in the code, we can see a templates folder has been created. Let's create a template in here that contains the contents for the homepage. You can create templates in here however you like. However, the convention is to create a directory that matches the controller name and a file name that matches the method name. So first, we'll create a subfolder called Home to match the home controller. The convention here is to use snake case instead of Pascal case, so in this instance the word home is all in lowercase. Inside this folder, let's create a new file called index to match the index method inside the controller. Again, this is in lowercase. For the file suffix, the recommendation here is to have two suffixes, one for the final format that the template will generate, so in this case we'll put .html. Alternatively, you could have .xml, .json, and so on. The second suffix is .twig to show that this contains Twig syntax. This helps in code editors for syntax highlighting. In here, let's just add a heading element. Then, back in the controller class, we can load and output the contents of this template. To do that, when the Twig bundle was installed, additional code was added to the framework to enable us to do this easily. To get access to this, we need this controller class to extend a base class. So first, let's import that class into the current namespace with a use statement. Again, note that you don't need to remember this path, it will typically be added automatically, as we'll see later on. Then the controller class can extend the abstract controller class. This class now inherits some methods for getting the contents of a template. So let's get the contents of the home index view we just created by calling the renderView method on the current object, passing in the path to the template. Note that this path is relative to the templates folder. This returns a string, so instead of the hard-coded message we put earlier, when we return the response, let's pass in this string. In the browser, when we run this, now we get the contents of the template. Instead of rendering the contents of this view into a variable, then creating a new response object and returning it, there's a shorter way of doing it. The render method will do the same, and return a response object. So we can just call render, passing in the path to the template, and return this method call's return value directly. When we run this, we get the same result. As for the rest of the HTML, such as the doc type, head section and so on, we could add this to the template, but this is code that will probably be common to several different templates. Instead of repeating this code in each template, Twig enables us to use template inheritance. This allows us to define a parent template containing common code and child templates that extend this. When the Twig bundle was installed, in addition to the templates folder, inside that folder there's also a file called base.html.twig. Inside that we have a basic HTML file containing a doc type and a head and body section. There are also several blocks defined, which uses not PHP but Twig syntax. When we extend this base template, we can optionally provide content for each of these blocks. So back in the index template, to extend the base template, first we add some Twig syntax at the top to say that this template will extend the base template. Note how this path is again relative to the templates folder. If we run this now, we get an error, with a helpful message saying we have content outside of Twig blocks. The base template defines different named blocks into which we can insert content, for example title or body. Back in the index template, to define content for a block, we enclose it in Twig code where we can specify the name of the block we want to insert the content into, putting an end block line at the end. Now when we view this in the browser, the error has gone. If we view the source, we can see the content of the index template has been inserted into the base template, resulting in a full HTML document. So we just created a view template and a controller to render some content in a browser. Instead of creating this manually as we just did, Symfony provides some tools to generate code like this automatically. The bundle that provides this functionality is called the Maker bundle. We can install it using Composer with this command. However, as we're using Symfony Flex, the Composer plugin that modifies the behavior of Composer, there are shortcuts that we can use for this. When Symfony Flex installs a package, the additional code that runs to configure the framework, create files and so on is called a recipe. Several of these have aliases. These are short names which make it simpler to install. There's a list of them in this repository, and if we go down to the Maker bundle, we can see that it has these aliases: generator, make, maker, and so on. Let's take a look at the current terminal commands that Symfony has provided. As part of the framework, there's a PHP script in the bin folder called console. If we run that, we see the available commands for clearing the cache, listing routes, and so on. We'll look at some of these in more detail shortly. To get a list of all available commands, we specify the list option. Note that depending on your environment, you might be able to run this without prefixing it with PHP like this. Let's go back to installing the maker package. So what the alias lets us do is install this package using this composer command, composer require maker. If we ran that in a regular PHP application without Symfony, then we get an error. Package names always need to be something / something else. As these maker commands are only going to be used when developing, let's add the dev flag to just install this for the development environment. When I run that, it installs the maker bundle and configures it for use in the framework. Now that it's installed, if we list the available console commands, we can see there are now many more available in the make namespace. One of these is for generating a new controller class. If you want to see more details about what a specific command does, you can use the help command, followed by the name of the other command. This shows us what this command will do and its various options. Let's use it to generate a controller. You can use it like this, specifying the name of the controller after the command. You can also leave this out, and the generator will prompt you for the name. Let's generate a controller called product for showing product data. Note how I'm just entering product in lowercase for the name, and when I run this, the actual name of the file is product controller. The suffix controller has been added automatically, and the file name is in Pascal case. Note also that a template has been generated in a folder that matches the controller name in the templates folder. Let's have a look at the controller code. The class that has been generated includes the namespace. It extends the abstract controller class and includes an index method with a root. Inside the method, it's rendering the index template that was generated. In fact, if we compare this with the home controller class that we created manually, it's almost identical. So you don't need to remember all these namespaces or create controller classes manually. It's much faster and more convenient to use the maker bundle to generate the code. There are only a couple of differences between this product controller and the home controller. First, the root has a name specified. This allows us to refer to roots by name when generating links or redirecting. This name can be anything you like, as long as it's unique. Let's change this generated name to product_index. The other difference is the call to the render method. The second argument is an associative array containing one element. This is how you pass data to a view template. Note that the index of the element is controller_name. Let's have a look at the template that was generated in the product folder inside the templates folder. In here, just as with the home index we created, it's extending the base template and provides content for both the title and body blocks. Inside the body block, we see this syntax: two sets of curly braces. Inside this is the controller_name value we saw in the controller. This is how we output data that's passed to a template. We'll see more examples of this shortly. Back in the product controller, we can see that the root path generated is /product. If we go to /product in the browser, we see the rendered contents of this template. Let's use this root name to link to this page from the index page. In the home index template, let's add an anchor tag that links to the product index. For the value, let's use the Twig two curly braces syntax. Inside this, to generate a path based on a root name, we use the Twig path function, passing in the root name. Now in the browser, on the home page, there's the link to the product index. Note that the path function generates a relative URL. If you want an absolute URL, there's an alternative function available called URL. There's a full list of available Twig functions in the official documentation. One of the advantages of generating the URL based on the root name is that it makes the code more robust. For example, in the product controller, let's change the path of the product index root from /product to /products. So if you give your routes names and use these names instead of the paths, you can easily change the paths without breaking your application. If at any time you want to see the currently defined routes, on the command line you can run the bin console debug router command. As routes can be defined in several different controllers, this is useful if you want to see the current route names and paths. Note that although the home index route doesn't have a name defined, one has been generated automatically, app home index. The other route is used for previewing error pages and has been included automatically by the framework. Now we have a controller and index method to display a list of products. Let's get that data from a database. In a plain PHP application, you might use PDO to connect to a database, writing SQL directly to send queries to the database. To work with databases in Symfony, we use the Doctrine library. This provides a robust and powerful set of components that makes working with databases easy. To install Doctrine support, we need to install the ORM pack. Packs in Symfony are just shortcuts that enable us to install multiple packages at once. So on the command line, let's install the ORM pack package using Composer. When you install this, it will ask you if you want to include configuration for Docker, which you can if you're using that. I'm not, so I'll say no. Once installed, the installer suggests that the next thing we do is to modify the database URL config in the .env file. Let's open the .env configuration file, which is in the root of the project. If you're not familiar with .env files, I have a separate video all about that, and there's a link in the description. This section of the .env file has been added by the Doctrine installer. The database URL setting configures Doctrine to connect to the specified database. By default, this is set to Postgres, but there are commented out settings for other common DBMSs, such as SQLite and MySQL. You need to change this value so it contains the settings for the database you're going to use. There are examples of values for different databases in the official documentation. I'm going to use SQLite, so I'll comment out the Postgres line and uncomment out the SQLite line. For SQLite, all we need to configure is the file name. This value surrounded by %signs denotes the project folder, and within that, the default value is data.db inside the var folder. The var folder was created automatically when the project was initialized, but I'll change the default data.db file name to products.db. On the command line, if we list the possible console commands, we can see that several Doctrine ones have been added. Now that we've added the database configuration settings to the .env file, we can create the database. We do this with the Doctrine database create command. As I'm using SQLite, this has created the file products.db in the var folder. If you're using another DBMS, such as MySQL, then this will have created the database inside that server. Now we have the database, we can add some tables to it. In a traditional PHP application, you would typically use a database tool to add tables to the database directly. For example, as I'm using SQLite, I could use the DB browser tool. If you're using MySQL, you might use phpMyAdmin and so on. Instead, in Symfony, the code to define the database tables is part of the project codebase. This makes it much simpler to share the database schema with other developers, and to deploy the code to another server. First, we need to create an entity class. An object of an entity class represents a single record in a database table. When we installed Doctrine, an entity folder was created inside the source folder, which is where we store the entity classes. Note that a repository folder has also been created. Instead of creating this class manually, there's a generator we can use for this. So let's create an entity called Product. This creates a class called Product in the entity folder, along with a class called Product Repository in the repository folder. However, this generator hasn't finished yet. It will also interactively add properties to the entity class, which here it refers to as fields. Let's follow the prompts. We'll start with a property called name. Property names in PHP should be in camel case, so we'll specify it starting with a lowercase letter. Then we're prompted for the type. If I enter a question mark, it shows us all the available types. We'll specify this one as a string. For the length, in this case, it will be the number of characters. Let's specify 1 to 8. Next, we're asked if this field can be null in the database. Note that if I don't specify anything, the default value is what's in these square brackets at the end, in this case no. So if I just press enter, no will be specified. Now that property has been added. Let's add another one, this time called description, and we'll make that a text type that can be null. Finally, let's add a property called size, which is an integer and can't be null. To stop adding fields, we just press enter. Let's have a look at the entity class, the file product.php in the entity folder. If we ignore the attributes for the moment, we can see that this is a basic PHP class called product that doesn't extend anything. It has several private properties that match the ones we added with the generator. Name, which is a string, description, also a string, and size, which is an integer. For each of these private properties, there are public getter and setter methods. There's also an integer ID property, which only has a getter method. The generator has also added several attributes. These define the characteristics of the fields that will be created in the database table. Note that although this class was generated, you are of course free to edit it however you like. There's a full list of possible attributes in the official Doctrine documentation, although when adding properties, using the generator is usually sufficient. These attributes are used by Doctrine to generate the code that will actually create the table in the database. This code is called a migration. To create the migration code, we use the make migration generator. This creates a file in the migrations folder. Note the file name contains the current timestamp, which is used for versioning. Let's have a look at that file. It's a class that contains a method called up, which contains the SQL to create the product table. Again, although this is a generated file, you are free to edit it however you like. This isn't usually necessary though. To run this, we use the Doctrine migrations migrate command. When asked for confirmation, I'll just press enter, which answers yes, and we get a message saying the migration was executed successfully. Let's have a look at the database in the SQLite database browser, and there we can see the product table has been added. The table contains the fields with their types that we specified in the entity class. There are also a couple of other tables. The Doctrine migration versions table is used by Doctrine to keep track of which migrations have been executed, and the SQLite sequence table is used internally by SQLite for auto-increment fields like the ID column in the product table. You can safely ignore these two tables, you don't have to interact with them at all. As for the product table, let's say you want to add another field. You could manually edit the entity class again, adding a private property with the appropriate attributes, along with a public getter and setter method. Alternatively, you could run the entity generator again, and it will edit the existing entity class. Now we have a database table, we can start working with it. First, let's see how we retrieve data from a database table using Symfony. For that, we need some data in this table. Now we could insert some data directly using a database browsing tool like this one. There's an alternative, however. Fixtures are used to load data into your database for testing or just to have some data while developing. To enable support for fixtures, we need to install the Fixtures bundle. As we're using Symfony Flex, we can do it with this alias. So on the command line, let's install that with Composer, specifying the dev flag as we don't need it in production. This has created a folder called Data Fixtures in the source folder, and in there a class called App Fixtures. This class is ready for us to add code to create some data. First, let's add a use statement for the product entity class. Then, inside the load method, let's create a new object of that class, then use the setter methods to set values for the name, description and size of that object. To create this object in the database, we use the Doctrine Object Manager, which has already been passed to this method as an argument. So we call the persist method on this object, passing in the product entity object. Let's add another product, this time with different values for the name, description and size. Again, let's call the persist method to create it. Calling the persist method doesn't actually save these values to the database. To do that, we need to call the flush method, which will load them into the database table. To run this, we use the Doctrine Fixtures load command. Note that this will remove all data from every table in the database before it runs. If you want to just append the fixture data, you can specify the append flag. The database is currently empty, so I won't include that flag. Let's run that and confirm that action by typing yes. To check that that worked, we could use the database browsing tool to look at the table directly. However, we can also query the database here using the console. Using the dbal run SQL command, we can execute any arbitrary SQL directly from the command line. Let's select all the records from the product table. Note you have to enclose the SQL string in quotes. And there we can see the two records that have been inserted into the product table. Now we can display this data in the web browser. Here in the index method in the product controller, we're currently just rendering a template. Before we do that, let's retrieve some data. In a plain PHP application, we typically do this by connecting to the database and executing some SQL. Symfony, though, provides us with tools to make this much easier. When we generated the product entity class, a product repository class was also generated in the source repository folder. There isn't actually much in this class, but it does extend this Doctrine Service Entity Repository class, which provides a lot of functionality. So we can use this class to select data from the product table. Back in the controller, first let's add a use statement for the product repository class. Then, in the index method, let's try creating an object of this class. When we run this, we get an error. Too few arguments to the repository class constructor. If we look at the product repository class, we can see the constructor has an argument of a manager registry class. Rather than try and find this object, which could have its own dependencies, there's another way of doing it. Symfony contains a component called a service container. A typical Symfony application is full of useful objects, for example a class for logging, one for sending emails and so on. These objects are referred to as services. At the moment, we're interested in getting access to a repository object. The service container makes it easy to create objects that we need in our applications. For example, in a controller, we can ask the container to return an object of the class we want by simply type hinting an argument with the service name or object class. So in the index method of the controller, instead of trying to create an object of the repository class directly, let's add an argument to the method with a type declaration of the product repository class. Now when we run this method, the error has gone. The service container will pass an object of this class to the method when it executes, automatically resolving its dependencies on other objects, so we don't have to. Now that we have a repository object, we can use it to retrieve the data from the project table in the database. The repository object has several methods for retrieving records. Finding an individual record based on its ID, finding one based on the value of a column, or getting all the records. Let's use that findAll method to get all the product records from the database. Let's see what this method has returned. For debugging, Symfony provides the dump method, which is like the var dump method in PHP, but formats the data in a more helpful way. When we run this, we get an array with two elements. Each element is an object of the product entity class, and if I expand these, we can see the values of the records that have been retrieved from the database. Note how after this debugging data, the index template has been rendered. This is because the dump method doesn't stop execution after it runs. There's an alternative DD method, short for dump and die, that will output the specified data and then stop the script. So now when we run this, the template isn't rendered as the execution stopped before the render method was called. This is useful for quick debugging if you want to see the value of something, but you're not interested in the rest of the script after that. Now that we have this data, let's pass it to the template so that we can display it. So instead of assigning the data to a variable and then outputting it, let's pass it to the template when we render it, with an index of products. Then in the product index template, let's remove this generated content from inside the body block. We'll replace that with a heading element and a table with a header containing heading cells for each of the product's attributes apart from the ID, and a body section. Then, inside the table body, we need to loop around the array of products to display each one in its own row. In a plain PHP application, you might do something like this, using a PHP for each loop, then printing out the properties of each object using the short echo syntax. In Twig, however, there is a much simpler syntax available to do this. Inside a curly brace and %sign, we can just say for product in products. Then, to access the name property of the product object, we just use a dot or period. Let's add table cells for the description and size properties too. Finally, we end this with an end for command. Let's have a look at that in the browser, and we get a table containing the data of the two product records. Note that we haven't applied any styling to this page. Styling is beyond the scope of this tutorial, but a very quick way to add styling without having to add any classes or any additional HTML elements is to use a classless style sheet like simple.css. To use this, we'll just copy the HTML code for the CDN hosted version of the style sheet. Then in the base template, we'll paste that in the head section of the HTML. Now in the browser, we have a nicely styled page. As I added this to the base template, then these styles are applied to every page, so the home page also has these styles applied. To display these records, we used the product repository class to retrieve the data from the database, so we didn't have to write any SQL. So this class is generating the SQL and running the query for us. What happens though if you do want to see that SQL? Symfony provides a tool called the Profiler, which gives us detailed information about any request. To install it, we use Composer to install the Profiler pack. So on the command line, let's install that, making sure we specify the dev flag, as we most certainly do not want this to be enabled in production. Now if I go to the product index page, a toolbar appears at the bottom. If I hover the mouse cursor over some of these values, it gives us details of the request, such as how long it took, the number of database queries, and so on. If I click one of these panels, for example the database panel, then we go into the profiler itself. In here, we can see the number of queries that were executed and the SQL. There's a wealth of information in here. For example, the Twig section shows us which templates have been rendered and the blocks within them. Note that the profiler has added several templates in order to show the toolbar, but these will only be shown in development. I encourage you to click around the profiler to look at the available information, as it's an extremely useful tool when developing. Now we're displaying the list of all the records, let's add code to show an individual one. In the product controller, let's add a new public method called show, and this will return a response object. Before this method, let's add an attribute to specify a route. For the route path, we want to be able to identify an individual product. If we add a segment to the URL inside curly braces, then this segment will accept any value. This is called a route variable. I'll give it the name ID. Now that we've done this, we can add an argument to the method with the same name as the route variable. Inside the method, let's use the dd function to print out the value of this argument. So now in the browser, if we go to /product/123, we get 123 printed out. In fact, if I put any value at all in that segment, this is the value that's sent to the show method when it's called. By default, a root variable will match any string in that segment. We can restrict this using regular expressions. We do this by specifying a regular expression after the root variable name inside less than and greater than characters. For example, let's restrict this to a string of one or more digit characters. Now when we try and match this root, numbers in this root segment still match, but if I put a value that isn't a number, we get a 404 not found response. Note that when we use the dd function, the profiler isn't shown. Now we have an ID, we can use it to retrieve the product record with that ID. Before we do that, let's render a template so that the profiler toolbar appears and we can view the SQL. So let's create a file in the templates product folder called show.html.twig. In here, let's extend the base template and provide content for the body block. For now, we'll just put a heading. Then, back in the product controller, instead of outputting the ID, we'll render the show template. So now, with a valid number in the URL segment, we see that template. Before we render the template, we need to get the product record with the specified ID. I'll come back to this in a moment. First, let's pass this variable to the template when we render it. Then, in the show template itself, let's add a table to display the product data, the name, description, and size columns. So now we can get the product record into this variable. There are several ways we can do this. Let's start by using the product repository. So just as with the index method above, let's add an argument to this method for an object of that class. Note the order of these arguments doesn't matter. Then let's use the findOneBy method of the repository class. The argument to this method is an associative array containing where clause conditions. So let's specify that the ID column should be equal to the ID argument. Before we try this, let's just run some SQL on the command line to see what IDs are available for valid records in the database. So if I specify the ID of 1 in the URL, we see the data for that product record printed out. If I click on the database panel of the profiler, there's the SQL that was generated to retrieve that record. As we're using the ID column, we can just use the find method, which does the same thing. And in the browser, this gives the same result, albeit with slightly different SQL. If I enter an ID that doesn't exist though, we get an error from the template, trying to access the name attribute on a variable that contains null. If a record isn't found that matches this ID, then the find method returns null. In this case, we want to return a 404 not found page. So let's check for that, and if it is null, we can throw a not found exception by calling the createNotFound exception method of the controller class. So now if the ID isn't found, we get an HTTP 404 response. Note that this response, showing all this data, is the response we get in development, so we can see all this useful debugging information. To see what this looks like in production, in the .env file in the root of the code, let's find the app.env setting and change it to prod. Now in the browser, we just get a generic 404 not found page. As we're developing, and we do want all the useful debugging information, let's change that back. Back in the controller, as we're retrieving a single entity object based on its ID, there's a shorter way of doing this. Instead of specifying the ID as an argument, we can put an object of the product entity class directly. We then no longer need the product repository argument, and we can get rid of all this code that uses that repository class and also returns the 404 response if the record isn't found. As the product argument has the same name as the variable we were just using, this will be passed to the view as before. Note that so we can use the entity class like this, we need to add a use statement for it at the top. In the browser, if the ID is not found, we still get a 404 response. If the ID exists, then the product record is retrieved, and we see its details as before. Now we can show an individual record. Let's link each record on the index page to its corresponding show page. First, let's add a name to the root for the show page. Then, in the product index template, let's enclose the contents of the table cell where we're displaying the product name in an anchor tag. For the value of the href attribute, we'll use the path function to link to the product show page, using the root name we just added. To pass a value to a root that contains a variable, we pass a second argument to the path function containing a Twig mapping. This is a list of keys and values wrapped in curly braces. So we'll provide a value for the ID variable, which is the ID property of the current product. If we look at the product index in the browser, now each row contains a link to the show page for that record. Next, let's add a form for inserting a new record. Here in the product controller, let's add a new method called new that returns a response. We'll also include a root with a name, and inside this method, let's render a suitably named template. Let's create that template in the Templates product folder. Inside this template, we'll extend the base template and add some content for the body block that contains a heading element. In the index template, let's link to this page using the root name. In the browser, on the index page, there's the link, and if I click it, we go to the new product page. Next, we need to create a form so we can submit data to be saved. Instead of writing the HTML for the form manually, Symfony provides a powerful form component that will handle creating the form and also processing it, including redisplaying invalid data and much more. To install the form feature, we use this command with Composer. So let's run that command on the command line. You can create a form inside a controller method, but the recommended way is to create a form in its own class, thereby keeping the controller code as short and simple as possible. As we have the Maker package installed, there is a generator we can use for this. So let's run the console make form command on the command line. For the name of the form class, I'll put product. The next prompt is asking us to optionally bind the form to an entity class. As we're using the form to save a product record, we can specify the product entity class. This has created the product type class in the source form folder. In that class, there's a build form method that adds 3 fields, one each for the name, description and size properties of the product entity. The configure options method below is where this class is linked to the product entity class. Let's just accept these defaults for now. In the product controller, let's add a use statement to import this product type class into the current namespace. Then, in the new method, we use the createForm method of the controller class to create a form object, passing in the class of the product form. We'll then pass this to the view when we render it. Then, in the new view template, to render the form, we use the form function, passing in the form variable. In the browser, there's the form. Each field has been generated with the type that corresponds to the type of data. The name is a text input, the description is a text area, and the size is a number type. In the product form class, when these fields were added to the form builder, the types were calculated based on the types of the columns in the product entity. This is fully configurable, so we can set various options on these, change the types and so on. Let's see an example of this by adding a submit button to the form. Before we do that, note how the generated name of this class is product type. In Symfony, form types include single inputs, a group of inputs, and an entire form. These are all referred to as types. There are several provided by the framework, and you can define your own. To add a submit button, let's use the submit type. So in the product type class, let's add a use statement to import the submit type into the current namespace. Then, in the build form method, let's add a type of this class to the form. In the browser, the form now has a submit button. There are various different options we can set for these types. For example, let's change the default label on the button. We do this by specifying an array as an additional argument to the add method. Now in the browser, the label text on the button has changed. So you can create the form entirely in PHP code like this, and just render it in the view with the Twig form function. Alternatively, if you want more granular control over how a form is rendered, there are other functions for rendering just parts of forms. There's a full list in the documentation. For example, the form function that we're using renders the entire form. The form start function just renders the form opening tag, and so on. So let's change the new template to render the form in parts instead. So rather than use the form function, let's just call the form start function. We still have to pass in the form variable. After this, let's call the form row function for each row, which we can access as properties of the form variable. Finally, we'll call the form end function. We can also set properties in here. For example, let's set the label of the submit button. Note that this way you could wrap each element in HTML, or even hardcode the HTML for the submit button, and so on. When we run this, we get the same form displayed, but note the submit button label has changed to what I specified in the template. The value in the template will override the value from the form class. Now we have the form, we can add the code to process it when it's submitted. In the product controller, we could add another method with a corresponding route and configure the form to request that method when it's submitted. However, it's recommended to handle the form submission in the same method. If we look at the generated source code for the form, we can see that it doesn't contain an action attribute. This means that when it's submitted, it will request the same URL. So in the new method in the controller, we need to detect if the form has been submitted or not, then access the form data. In a regular PHP application, you typically check the server request method, then access the form data in the post superglobal. However, in Symfony, this data is encapsulated in an object that represents the request. This means we can avoid using superglobals. To use the request class, first let's import it into the current namespace with a use statement. Then, back in the new method, to get access to the current request, we can add an argument to this method with a type declaration of that class. Then we call the handleRequest method on the form object, passing in the request. So instead of using the superglobals to see if the form was submitted, we call the isSubmitted method. To access the form data, we use the request property of the request object. It's referred to this way as post values are commonly referred to as request values. The all method returns all of them in an array. Let's print that array out. Let's give that a try. If I click on the new product link from the product index page, we see the form. So the code has detected that the form hasn't been submitted yet. If I enter some values and submit it, we get the data from the form printed out. However, we don't need to access and assign these values directly from the request. First, we'll assign the values from the form to a product entity object. So at the top of the method, let's create a new object of that class. Then, we pass that as the second argument to the createForm method. In addition to assigning the values from the form to the entity, This is also used when we redisplay the form, so it contains the originally entered values and also displays the validation messages. We'll see an example of this shortly. To save the entity, we need the Doctrine Entity Manager service. This is an object that is responsible for saving objects to and retrieving objects from the database. To get the Entity Manager object, first let's add a use statement for its interface. Then, as with the request, we add an argument to the new method, type hinted with this interface. So once the form has been submitted, to save the data, first we call the persist method of the Entity Manager, passing in the product entity object. Then we call flush to actually save this to the database. Instead of printing out the request data, let's output the product entity object. So with values in the form fields, when I submit the form, we see the product object. Note how it now has an ID assigned. If I go to the product show page, passing in that ID, we see that product, meaning that a new record has been saved to the database containing the values from the form. Let's redirect to this page from the code. So instead of printing out the product entity object, we'll use the redirect to root method of the controller, passing in the root name and the ID of the product, which we can get from the product entity's getID method. Let's give that a try. If I enter valid values into the form and submit it, a new record is inserted and we're redirected to the show page for that record. Going back to the form, if I submit a form without entering any data, we get some basic HTML form validation. This is included by default and is based on the properties we specified when we generated the entity class. For example, the name field is required and the size should be a number. Let's disable this validation to see what happens. In the new template, we can specify the HTML noValidate attribute when we render the opening form tag. So now if I refresh the form and submit it without entering anything, the HTML form validation has been disabled, the form is submitted, and we get an exception. Using the profiler, we can see that the SQL that the code is executing is trying to insert null values into the product table. As we specified that the name and size columns couldn't be null, we get the integrity constraint violation. So we need to validate the data on the server before we try and insert a new record. To do this, let's install the Symfony Validator component. So on the command line, let's install that with Composer. To use the validator component, we configure rules in an entity class that will tell the validator if an object is valid. These rules are known as constraints. Symfony includes many commonly needed constraints, such as making a property required, a certain format like email, and so on. So, in the product entity class, first let's add a use statement to import the parent namespace of these constraints, giving it an alias of assert. This alias is optional, it just makes the code more readable when we use it. To add a constraint to a property, we use an attribute. For example, before the name property, let's add an attribute that tells the validator that we want this property not to be blank. So this reads that we want the validator to assert that this property isn't blank. Some constraints have options. For example, the type constraint validates that a value is of a specific type. We specify the type as a string argument. So for the size property, in addition to asserting that this isn't blank, let's assert that it should be an integer. Let's also assert that it should be a positive number using the positive constraint. Note that you can specify these constraints in a separate configuration file if you prefer, but it's more common to use attributes as we have here. To actually validate a product object, we need to use the validator service. We could get this by injecting this service into the controller method, as we've done with other objects like the request. However, the form component is integrated with the validator. So if the form is submitted, let's also check to see if it's valid with the isValid method. Let's give that a try. If I submit an empty form, we get validation messages next to the name and size fields saying they shouldn't be blank. If I enter a value for the name, but a negative number for the size, then we just get a message saying the size should be positive. Note how the originally entered values in the form are preserved when the form is redisplayed. If I change the size value to a positive integer, then the validation passes and the record is inserted successfully. One more thing we can do on this page is to display a message to say that the record was indeed saved successfully. These are commonly known as flash messages. This uses the session to store the message between requests, but this is all handled automatically. You don't have to explicitly start the session. So in the new method in the controller, before we redirect to the show page, let's add a flash message with a type of notice and a value containing a success message. To display these messages, there are several Twig code snippets in the documentation that show how to display them in different ways. Let's copy the one that just shows the notice type. In the base Twig template, at the top of the HTML body element, let's paste this code. I'll change the class of the div element to just notice, as this is a utility class that's part of the simple CSS style sheet we're using. Let's give that a try. As there are currently no flash messages in the session, nothing is displayed. If I insert a new record, we're redirected to the show page, and there's the flash message. If I refresh this page, then the message disappears. Next, let's add functionality to edit an existing record. Here in the product controller, let's add a new method called edit. We'll need several arguments for this. First, a product entity object to identify the product we're editing, similar to the show method above. We'll also need a request object and access to the entity manager to save the updated product, similar to the new method above. As always, this will return a response. As for the root, this will need a root variable for the ID, and as with the show method, we'll restrict this to just digits with a regular expression. Let's also include an appropriate name. Inside this method, let's start by doing the same things we did in the new method. So let's go up to the new method, copy its contents, and paste them inside the edit method. At the top of the method contents, we don't need to create a new product entity object, as we're getting this as an argument to the method. Once we've checked to see if the form has been submitted and that it's valid, we also don't need to call the persist method, as the record already exists in the database. Let's change the flash message so instead of created, it says updated. At the end of the method, instead of rendering the new template, let's render one called edit. To create the edit template, we could copy the new one. However, we'd be duplicating all the code inside this template. To avoid repeating ourselves, let's extract the common code out into a separate template. First, let's create a new file in the templates product folder called form.html.twig. As this template doesn't correspond to a method in the controller, it's common practice to begin the name with an underscore. Back in the new template, let's select all the code that displays the form, cut it, and paste it in the underscore form template. Then, back in the new template, at the point where we just removed all this code, to include the other template in here, we use the include function, passing in the path to the form template. Let's check that the new product form still works, and it does. So now we can create the edit template by first making a copy of the new template. In the edit template, let's change the heading from new to edit. Finally, in the show template, let's add a link to the edit page, making sure we pass in the product ID. Let's give that a try. If I select a product, there on the show page is the edit link. If I click it, we're shown the form, and the existing record's values are shown in the form fields. Let's check the validation by entering an invalid value, and that works as the form is shown again with the validation message. If I correct this, and also update some of the values and click Save, the values are updated, and we're redirected back with the flash message saying the product has been updated. Finally, let's add functionality to delete a record. In the product controller, let's add a new public method called delete. Let's add arguments for the request, the product entity object, and the entity manager. As always, this will return a response. Let's add an attribute that specifies a route, including a numeric ID variable and a suitable name. Inside this method, let's render a template called delete. In that template, we'll need the product ID, so let's pass that in when we render it. In the Templates product folder, let's create that template. In here, as with the other templates, we'll extend the base template and provide some content for the body block. Inside this block, let's add a suitable heading followed by a confirmation message. To delete a record, as we are changing data on the server, we need to use the post method. To keep this simple, we'll create a form directly in HTML. This will just contain a button. We'll follow this with a cancel link that links back to the show page. This is why we needed the product ID. In the show template, let's add a link to this page after the edit link. So on the show page, there's the delete link, and if I click it, we see the delete confirmation page. Clicking the no link takes us back to the product show page. Now we can process this form when it's submitted. As we haven't added an action attribute to the form, when it's submitted, it will request the same URL. So in the delete method in the controller, at the top, we need to detect if the form has been submitted or not. We can't use the isSubmitted method we used above, as we're not creating a form object. Instead, let's just check the request method, which we can do using the isMethod method on the request object. If this is post, then we can call the remove method on the entity manager, passing in the product entity object. We then call flush on the manager object to commit these changes. Let's add a suitable flash message and then redirect to the index page. Let's give that a try. If I select the first record, click the delete link and then say yes on the delete confirmation page, then we're redirected back to the index page. The flash message is shown and we can see that the record has been deleted. So now we have all the CRUD operations completed for the product table: create, read, update, and delete. To do this, we've used packages for forms, validation, database access, templating with Twig, command line generators, and many other packages. Throughout this video, we've installed these packages as and when we've needed them. If we take a look at composer.json, we can see the packages that have been installed. Typically, when creating a web application with Symfony, you don't need to do this. If you specify the Webapp option when creating the application, then this will install and configure many of these packages when the project is created. Let's look at an example of that. On the command line, note not part of the project we just created, let's create a new Symfony application specifying the Webapp option. If we open the generated code for that application and open the composer.json file, we can see it includes a lot of packages by default. Ones that we're familiar with from earlier on in the video, like Doctrine and Twig, along with many others like the Symfony Mailer, which is a package for sending emails. If you're creating a new traditional web application with Symfony, including the Webapp option when you create it is recommended, as it installs and configures a lot of the packages that you'll typically use. Also throughout this video, we've used various generators from the Maker package to generate classes for entities, controllers, and so on. And the final result was a controller and associated templates that handled CRUD operations for a particular entity. There's actually a generator that will do this for you. First, as an example, let's create an entity class using the entity generator. I'll call it book and give it just a name property. Now we have an entity class, let's generate a CRUD controller for it. This prompts for the name of the entity class, so let's enter book, then the name of the controller class, for which it suggests a sensible default. Let's accept that, say no to the generation of tests, and there we go. This has generated a controller, a form, and several templates. This generated controller code looks a lot like the products controller we created earlier on in the video. As we built that controller from scratch though, you'll fully understand what all this generated code does. This generated code is a great starting point that takes care of the basics for you, so you can modify and build on it as you need to. There's a link to the source code shown in this video in the description, along with links to sites shown and other relevant videos. If you found this useful, please don't forget to like and subscribe. Many thanks to my supporters on Ko-Fi, and as always, thank you for watching.